when we were just discussing the R15 protocol of 5G, we mentioned two networking methods, right? One is standalone networking, the other is non-standalone networking. Actually, these two diagrams tell us what standalone networking is and what non-standalone networking is. That is the non-standalone networking in phase 1.1 and the standalone networking in phase 1.2. What are their characteristics? For this non-standalone networking, we see that the 5G base station needs to be networked with the 4G base station. Then it is followed by the 4G EPC core network. Of course, this EPC core network needs to be upgraded. In fact, it needs to be upgraded to EPC at this time. I will see that the dotted line represents our control plane signaling, the solid line represents our user plane data. We look at this NSA's 5G dual mode terminal, its signaling is on the 4G side. Only user data is on the 5G and 4G sides. That is, the 4G side carries both signaling and data. The 5G side only carries user plane data. So we would say this is a non-standalone network. 4G and 5G are coupled together, but the value this method brings is I can rely on 4G. To quickly complete the construction of the 5G network, I only need to deploy a small number of 5G sites in some hotspot areas to let it access the existing 4G network. In this way, I can quickly complete the deployment of 5G and quickly provide some eMBB scenario services. This is the commercial value brought by our non-standalone landmine networking. It can help operators quickly build networks and quickly gain this brand competitiveness, but its characteristic is that it does not support slicing. And the future standalone networking, we will find that 5G and 4G are mutually decoupled. 4G is 4G, 5G is 5G. The 4G base station is connected to the 4G core network through the S1 interface. The 5G base station is connected to the 5G core network through the NG interface, which is our NGC next generation core network. Then it has signaling on the 5G side's dotted line. This interface is called NGC200C, which is our control plane and also our user plane. Then the 5G terminal accesses the 5G core network through the 5G base station. This is our final SA standalone networking method. This standalone networking method can support slicing functions for vertical industries. But this standalone networking method requires us to deploy a 5G core network. At the same time, the number of our 5G sites should be as many as possible to achieve continuous coverage. Because only when you achieve continuous coverage, the user experience is relatively good. Otherwise, if you move out of the 5G coverage area, your 5G business will not be able to continue. So these are our two networking methods. They each have their own characteristics. NSA, SA allows us to quickly build networks. SA can support our future diversified slicing services, but SA is our final evolution network, the ultimate target network, because a very important point of our 5G is to enable vertical industries. It enables vertical industries through slicing, but only this SA standalone networking method supports slicing. Okay, these are our two 5G networking methods, NSA and SA. As for the characteristics, SA requires a 5G core network. For NSA, we can use the 4G core network. But the 4G core network needs to be upgraded. NG is called EPC. Okay, we have a thought question here. We introduced standalone networking SA and non-standalone networking NS. Earlier, we listed 7 characteristics here. Can support new URLLC business and combined with the existing 4G network, etc. These 7 characteristics. Which characteristics belong to SA standalone networking? Which characteristics belong to what NSA non-standalone networking? You can write your answers in our discussion area. Okay. This is our second part. We mainly introduced the 5G protocol, a standardization progress. In fact, our entire standardization, you can just look at the blackboard. We start from R15, then R16 will have continuous enhancements. R17 will actually define the technical standards of mMTC, of course. To cope with competition, we split R15 into phase 1.1 and phase 1.2. To deal with our non-standalone and alone networking, they are called our non-standalone networking and standalone networking respectively. But there is also a light drop version later, 1.3. But this networking method, we may not use it in actual networking, so it was delayed a bit, but it doesn't matter much. Okay, this is our second part, that is our standard. Then we will mention a special scenario of URLLC and mMTC, because at the beginning of our 5G business, in fact, we will only use the eMBB business scenario. It will be the fastest commercial As for URLLC and mMTC, they will be relatively delayed. We also mentioned this. URLLC, it mainly reflects a control force. This control force is in this vertical industry, especially in this vehicle networking and intelligent manufacturing. It is very important. At the end of 17 years, the standard of this URLLC, in fact, in the 3GPP standardization organization, 45% has been completed. Then in the middle of the year, that is in June of our 18th year, then when the R15 standard landed, in fact, we have completed the basic version of URLLC, but it's just basic functionality. Then in R16, we will complete the full version of URLLC with full competitiveness. Similarly, in this URLLC scenario, end-to-end non-time delay is very important. We have to explore some of these solutions or technologies for reducing end-to-end network delay. We know that the entire wireless network will be divided into wireless base stations. Then the bearer network, or we call it the transmission network, including our final core network, end-to-end latency is often important. We need to explore ways to reduce end-to-end network latency. Some of these solutions or technologies, we know that the entire wireless network is divided into wireless base stations, then the bearer network, or we can call it the transport network, including our final core network. As for 5G, it is our 5G core network. But the end-to-end delay includes these three parts, including our wireless testing, including our transmission bearer network, including our final core network. In these three modules, we have to use some new technologies to reduce their delay. In the core network test, we need some new technologies to reduce delay. In the entire transmission bearer network test, we also need to reduce delay. In wireless testing, we also need to optimize the air interface to reduce delay. In this way, we can ensure end-to-end delay reaches a higher level, reaches a lower delay to achieve our URLLC scenario. Of course, we said URLLC can be quite good. It can be applied to our intelligent manufacturing field, vehicle networking field, including some robot fields. This is our second scenario, our LLC. It has high requirements for our delay. We need to reduce delay in the entire end-to-end network by using some new technologies. But the complete technical standard of URLLC will be completed in our R16. In R15, we only completed a basic version. mMTC is also what we just mentioned because it has to consider coexisting with the existing NB-IoT network and eMTC network. We know that many cities in our country now have already opened the NB-IoT network. Some cities have also opened eMTC, but this part of the investment, telecom operators have already invested a lot of money. If we now directly implement the new mMTC standard, the operators' early investment in NB-IoT and eMTC may suffer certain losses. So in March 2018, that is, at the 79th meeting of 3GPP's RAN, has been clearly stated in the R16 version of 3GPP, 5G will not be involved in LPWA, that is our low power wide area, that is low power network. In fact, it is our IoT technology. It is clear that 5G will not be involved in R16, the basic standard definition of IoT. So we also said it will push the basic standard definition of mMTC back to R17. Then in our current NB-IoT and eMTC technology will continue to evolve. Future 5G mMTC will also coexist with NB-IoT and eMTC, maintain a compatibility with our previous technology. So in the future, NB-IoT based on 4G, NB-IoT and eMTC, it can be embedded into the 5G system because 4G, NB-IoT and eMTC, they are all narrowband systems. The use of balanced resources is relatively small. It can be directly embedded into 5G, such a large bandwidth. So this is the scenario of mMTC. At the beginning of the protocol definition, it was considered to be implemented in R16, but later, due to NB-IoT and eMTC, the reasons for these two existing technologies, including our existing network, there has been a large-scale deployment, so it was considered to delay the technology of mMTC, ensure that telecom operators' previous investments can get some returns. Of course, we will also consider the future NB-IoT and eMTC and the forward compatibility and coexistence of 5G. Of course, we will also consider future NB-IoT and eMTC and the forward compatibility coexistence with 5G.